Okay, here's question 3. You're given a diagram which has a circle and 4 lines, each of which is tangential to the circle. 2 of those lines are the x-axis and the y-axis, and the other 2 lines are just tangents to the circle. And you're asked to find the value of k, which is a variable in the equation of one of those tangents. Now, the method that I have for solving this, I'm quite sure is not the shortest method, as I never use this piece of information that k is greater than 1. Nevertheless, my hint is just to take a look at that diagram, really think about what it means that the circle is tangential to the axes in terms of, say, its center point and its radius. Straight away then, you can tell a few things just from this diagram. The fact that the circle is tangential to the axes means that this distance here from the center right to the axis is the radius of the circle, and the same thing with the y-axis. So you can tell the center point of this circle is actually just r, where r is the radius. Secondly, you can tell the crossing points of this line here with each of the axes. You know that when the x-coordinate is 0, the y-coordinate has to be 2, and when the y-coordinate is 0, the x-coordinate has to be 2, just based on this equation of the line here. So I'm going to set up a couple of pieces of information for my own use here. I'm drawing this line L here that goes through the origin, goes through the center of this circle, and it goes through this point here, the point of contact between the circle and this line here. And that point I'm just going to call AA for the moment. So one of the first pieces of information I can tell about my new line is that the slope is 1. I'm using the coordinates r and 0, 0. I've specifically set up my line so that it goes through those 2 points, so I can use them then to find this slope here, which is 1. So with that information then, I can find out the equation of that line using this formula here, which again is page 18 of the table book. Substituting the point 0, 0 in here and the slope, which is 1, I get that this is the equation of my line L, and I'm going to call that equation 1 for the moment. With that equation of the line and the equation of this line here, which I'm calling equation 2, if I solve them simultaneously, I'm going to get the point of intersection, which is right here. So I say y is equal to x from equation 1, y is equal to minus x plus 2 just from rearranging equation 2. The x's cancel when I add them together, so I get 2y is equal to 2, so y is equal to 1. And since y is equal to x, I know from equation 1, then x is equal to 1. Now I'm going to use that knowledge to find r, the radius of that circle. If this is the equation of the circle here, substituting r in for the coordinates of the center and r as the radius as well, then if I can find any solution to that equation, I'll know I can find r. Well, I happen to know that this point here is on the circle and that point is 1, 1. So I can substitute in 1 for x and 1 for y, and I'll know that's a valid solution and will let me find r. Just following the maths through then, I just tidy that up and I get r squared minus 4r plus 2 is equal to 0. Now, unfortunately, we can't solve this one by factorization, so we're going to have to use the quadratic formula. In this case, a is 1, b is minus 4, and c is plus 2. So I slot everything in, I get 4 plus or minus the square root of 4 squared minus 4 times 1 times 2, all divided by 2 times 1. So you run that through, and you get towards here where you have 2 solutions. Now in fact, I can eliminate one of those solutions. If I run this through the negative solution, I'll get something that's less than 2. But if we take a look at this diagram here, this point here is 2 units away from the y-axis, but r is even further away than that. So I know that r can't possibly be less than 2. So that means I only have one valid solution at the end, and after you tidy it up, you get 2 plus root 2. So now I want to try and find out what this point AA is. And to do that, I'm going to use this triangle that we have. It starts at 0, goes over to A, and goes up to a height of A as well. So I know that both of these sides here have a length of A, so that's what I've drawn here. These 2 sides have a length of A. This length here, we know it's across 1 and it's up 1, So you can use the distance formula to work out that the total length of that little bit there is root 2, which I have, that's what this little bit here corresponds to. Now with the circle, I know one radius is 2 plus the square root of 2. So this whole length here is twice that. It's the diameter. In other words, 4 plus 2 root 2. And I also know that because my line L here has a slope of 1, it makes an angle of 45 degrees to the x-axis, or pi over 4 or tau over 8, whichever way you're inclined to work. I'm just going to use trigonometric rules to work out what A is now. I know that cos of the angle is equal to the length of the adjacent side divided by the length of the hypotenuse. So that's cos of pi over 4 is equal to A divided by 4 plus 3 root 2. Now 2 of those root 2's are coming from here, and I've got another root 2 which is this small length here, so in total I have 3 root 2's. From then on I'm just going to follow through with the maths. The cos of pi over 4 is 1 over root 2, and from then on it's mainly just a bit of algebra, multiplying, dividing. The only non-trivial bit really is saying that 4 is equal to root 2 to the power of 4. In other words, root 2 times itself 4 times. Then I take root 2 out as being common, so I'm left with root 2 to the power of 3, which is 2 times root 2. And this 3 is on its own now that I've taken this root 2 out as being common. So cancel those root 2's and I get A is equal to 3 plus 2 times root 2. Now I know that my point AA here is actually on this line x plus y equals 2k. In other words, it's a valid solution. So I can replace x and y with A plus A is equal to 2k, which I do down here. So I get 3 plus 2 root 2 plus 3 plus 2 root 2 is equal to 2k. Just need to follow through on the basic maths then. Add these together, you get 6 plus 4 root 2 is equal to 2k. Divide everything by 2 and you get k is 3 plus twice root 2. It's worth checking just to make sure that k meets all the conditions you had at the start, which were x plus y is equal to 2k. That must be true because that's how we found k in the first place. The other condition, that k is greater than 1, well, k is 3 plus another positive number, so it's definitely greater than 1. We don't even have to put it in a calculator to find out.